Hi, in this video I'll be explaining how I made the robot such that I can handle all the navigation and guidance given in the problem statement. So starting with first I'll explain the degrees of freedom in this robot. So for this I just have a marker with an arrow mark. So if you can see, we have 4 motors in this robot, and these 2 motors are facing front. This is the front side of the robot. So front side, and these 2 motors will be facing front, and these 2 motors, if you can see, these are inclined about 45 degrees each motor to the submarine. So first let me start with the like front and back movement of the robot. So if you can see, when I'm giving inputs in this radio, if I'm giving front, you can see these 2 motors are rotating, and both are rotating in opposite direction to each other, but still the force will be this side. So this motor will provide a force vector facing this side, and this motor also will be providing a force vector this side. So both, if you take the resultant force will be forward. Okay, same way for backward. If I want to give back, this motor facing this side and this motor facing this side, resultant will be facing this side in the center. So the robot will move back. Now the same motor is used to yaw the robot, like in this, change the heading of the robot. So for that, what we are doing is, if I give yaw input, both the motors will rotate in same direction. So what will happen is, this motor will rotate, this motor will provide a thrust vector facing this side, and this motor will provide a thrust vector facing opposite side. So the resultant will be a moment created about the center of the robot. So that moment will make the robot yaw in one side. Same way, if I change the direction, it will create a moment in the opposite direction. Now if we want to move front but still make the robot turn left or right, what will happen is, I have done a mixing. All these equations are fed in the Raspberry Pi itself. This robot actually doesn't have any flight controller. What will happen is, if I want to keep moving front and still turn the robot left or right, I am just varying the thrust. For example, this motor will provide this much thrust, and this motor will provide half of it. So what will happen is, still the robot will be moving forward. Because of change in thrust, again there will be a moment created and the robot will yaw. So now that is over. We'll come to the next degree of freedom, this z-axis, moving up and down. For that, I am using these 2 motors, which are mounted near to the center of gravity, and these are mounted 45 degrees to each other. So now if I give up input, what will happen is, this motor will give a force vector in this direction 45 degree, and the other motor will provide a force vector this side. So both will be 90 degrees to each other, and the resultant force will be a vertical line. So that is how the robot moves up, and same way opposite, if you do, it will move down. And you might think, why these motors are mounted 45 degrees to each other? You can just mount it straight so that it will be simplified. Why I have mounted in this way is, the same motors I want to use it for lateral movement also. So I'll explain how. What will happen is, if for example, if I want to move the robot laterally to the left side, if I give roll left, what will happen is, this motor will provide a vector here in this 45 degree, and this motor, if you see, this will provide a force vector in this angle, 45 degree to the down. So the resultant force will be lateral force. Since these motors are mounted near the center of gravity, the resultant force will be a lateral movement. So with this we have 5 degrees of freedom. and I'll explain how I'll be using it in the guidance. So here this is the track from the problem statement. So our idea is we have a gate 1, gate 2 and all. So our idea is to minimize the number of components. That's why we didn't even keep a flight controller. The robot is stabilized with the buoyancy force itself. So here what we are doing is we have an algorithm where it can track this line, and based on the line width I am controlling the altitude. So here if you can see, the gate is 2 meters high. My robot, based on the line width, it will be always maintaining 1 meter altitude, and it will be proceeding forward whenever there is a detection. So in that case it will automatically move into this gate. So that is how I am doing. This process will happen till it reaches here, and we have this hue saturation value algorithm, HSV based color differentiation. In that we will differentiate between this orange color and red color. When it reaches this red color, we are giving an input to our servo motor. So as I explained in this in the marker video, we have a servo motor to release the marker. So we'll be releasing the marker in red color, and just after releasing that, we will be maintaining this red color bounding box in center of the frame, and the robot will be increasing the altitude. So automatically it will just pass through this circle as well. So that is how we had planned and coded the robot. That's it. Thank you.